So here's a fun little thing. This is the pico-8 fantasy console. The idea of a fantasy console is it's like a piece of software that recreates a computer system that could have existed but didn't. And you have all of these sort of virtual limitations added to it to make it fun to play with. The idea of the pico-8 is it's all to do with programming and games. And everything is included when you download the pico-8. You have to pay. I mean, it's £7 or something like that. It's not a lot of money. And when you have pico-8 open, you can, if you hit escape, this brings you to a code editor. This is where you can write your games. Just in here, it uses a programming language called Lua, L-U-A. Here you can draw your sprites. This is where you can draw your maps for the games. So think if you think of Mario, this is where you could actually draw your level out. Here you can make sounds for your games. And here you can create music for your games. Very, very cute. Let me just reboot this. Yes. Cute. So, what can you do with it? Well, let's go into the demos and we'll show a little bit of show off the sort of thing you can do. So, let's open up the Hello program, and if we run it, cute, very cute. But now if I hit escape, this is now bringing up the code for that little demo there. As you can see, it's all there. We have the sprites that are used in the demo. There's no map used on that demo, and here we have the pattern editor. So you can draw individual patterns here, and here you can... Oh, very cute, huh? Let's load another... LS for list. Let's open another demo. Let's open up... Load waves. Run. Ooh, very nice. See, mathematical formula. What this has as an advantage over an actual Commodore 64 or an Amstrad or something of that ilk is that it's a little bit faster. So when you're talking about mathematical stuff, it can handle pretty fast mathematical processes, so you're not really particularly limited by the processing power of the system. So that's the waves demo. So as you can see, it's just drawing a mathematical formula. You can't really use this for proper computing, so it's not really designed for that, as there's no real way of inputting anything other than keyboard control commands. So up, down, left, right, and 2 fire buttons are pretty much all you've got. There is a development mode where you can use a mouse, and so you could build an RTS in this, but it's not quite ready for prime time. So let's load another demo. Let's do dots 3D. If you run it, ooh. Now you see a Commodore 64 could do this, but it wouldn't run as smoothly. Isn't that pretty? Very nice. And again, it's all maths. Let's do the impressive one now. So this is a 3D engine, just built in pico-8. I'm using the arrow keys to move around. Obviously the pico-8 is not designed for this. I mean, this is the sort of thing that even the Amiga would have struggled with in the day, just to have such smooth 3D polygons. And if we look at that, now this obviously is very maths heavy, this game. And how it does it is it generates height maps based on colour. So I don't know if that interests you or not. Okay, let's reboot this, and I'm going to show you some basics on how to do it. So I'm going to go into the code editor here. Now, when you're in the code editor, just type some code. Let's type print. Oh, let's see if I can remember how to do it. Print. Open bracket. Hello. And then if I hit run, hello. That's it. Programming. Fantastic. That's all you need to do. What if you wanted to do hello loads of times? Well, let's get into the meat of things. So, function init, end, function, I'll explain what I'm doing in a second, update, end, function, draw, end. Right, so what I've done here is function init stands for initialize. So I have said to this, when I hit run, do this. And then I said, once the program's running, do this. And once you've done that, do this. Update is the maths, all the working out of the game, of the programming. And then draw actually sticks something on the screen. So first thing I'm going to do is in init, I'm going to type in CLS. Now, when I run the program, CLS stands for clear screen. So as soon as I hit run, it clears the screen. Function update. Got nothing to put in there yet. Let's do function draw instead. So now if I type print, same again. Open bracket, hello, end. Now if I hit run, what? It's the 10 go to 20, 20 go to 10 thing. Hello, all over the place. Well, that's cool, isn't it? Now this is a basic introduction to programming, object-orientated programming. All of these functions are individual blocks of code which can be called from anywhere in the program. So you can say, oh, do function, whatever you call it. So you can have a function called shoot. So every time you hit the fire button, you could say run function shoot, and that would handle all of the code that shoot something. So these three functions are baked into pico-8. So we have function init, clear screen, and initialize runs at the very start, and then doesn't get called again unless you tell it to. Update gets called 30 times a second. And draw is the same. But draw doesn't take precedence, draw takes precedence over update. So you've always got nice smooth scrolling on the screen. Okay, so okay, that's cool. So now what? We've got print hello. Let's see if we can make that a bit more interesting. So let's do print hello 4. See what that does. It's like orangey brown now. So the print command has an argument you can add to it. The next argument that it would accept is the color command. But if, and this is important, I can also feed it X and Y coordinates, so it will draw it in a certain place. I'll hit run now. There's hello in the middle of the screen. It is, and the H is in the middle, and then the rest of the text moves along. But it's not doing anything else, because it is drawing 30 times a second, or as fast as it can actually display, but it's drawing it in the same place, so you can't really see anything. So now we have text in control. If you want to find out the color that you add in, you can go to your sprite editor, and all of these are the colors. So see, that says there at the bottom, it says color 1, 2, 3, 4, and that's color 4. Let's change that to like a nice lime green, so we'll change that to color 11. Just because I like it. Hey. So that's all much of a muchness, isn't it? So what if I wanted my text to move around the screen? Then we have to do something called variables. So text X and text Y. So I'm going to declare a variable. A variable is, think of it like a container for something. It could be a number, it could be some text, it could be anything. But the idea of a variable is you can put that in your code and the variable stays the same, but you can then modify it later on. So I'm going to say text X equals 0 and text Y equals 0. And then if I go down to my print command, and instead of 64 I put text X and then text Y and run it. Right, so it's now put it 0. Just text x and text y equals 0. So why are you doing the same thing over and over again? Well, the reason being is let's do some updates. So function update. So if I say text, so this goes through, this loops around all the time. So while the program's running, these are constantly looking at stuff. So if I say text x equals text x, right, plus 1. So it's going to go through the programming loop. It only does this bit once. And then it gets to here, and then it starts going round and round and round. So every time it hits this line, it's going to say, oh, what's text x? And then it'll say, oh, text x is text x. But let's add 1 to it. So what's going to happen with this program now is the hello is going to move across the screen. If I run the program. Ah, no. There's a bug. Is it? So think about how I start this program off. I cleared the screen. Now, if I want the text to appear to be moving, I don't want to leave the previous version of the text on the screen. So if I go to function draw, but then I start with a clear screen again. So every time it's going to, just before it prints hello, it wipes the previous one off. Let's try that again. If I hit run. Ah, there we go. Hello. Hello goes away. That's cool, isn't it? So now let's make it act in a diagonal. Let's go text y equals text y plus 1. Now you can abbreviate this, but I'm not going to bother for the purposes of this small demonstration. So now it should run diagonally. Hey, hello, and off it goes. Well, that's cool. What if I don't want it to say hello? What if, say, for example, I wanted it to do something more interesting? Let's make another variable, and we're going to call this one counter equals 0. And counter equals counter plus 1. Now I'm going to replace the hello here with the variable counter. What do you think is going to happen? Well, let's have a look. Oh, look at that. So now we've got a text. So now all we're doing is we're using variables here. Why don't we have another variable? I'm going to call that one color equals 0. And color equals color plus 1. And then we're going to replace this last one with color. If I could type. And now, we have rainbow text that's counting up and flying around the screen. Well, that's all very good. I hear you cry. But what's the point of that? Well, how about if I'm going to remove this block of text here, and I'm going to create an if statement. If statements, think of it like English. If you have a situation where you want something to happen if you do something else, that's an if statement. So if btn, right, 1, oh no, let's do 0. If button 0, then text x equals, oops, don't need that gap there, equal, excuse me, text s, that's 1. And then I have to say, once you've done it, stop there. So I have to, it's if and end loop. So let's break down what I've just typed there. If btn, which stands for button 0, and what this means, this little section here, if button 0 is pressed, that's what button 0 means, if button means, and 0 is the button you're pressing, then text x equals text x plus 1. So if I run the program, nothing's happening. But if I hold down button 1, I'm moving that around. I'm going to change that to button 1. The reason I've changed that button 1 is on the right hand side, it's the right arrow key, button 1, while button 0 is the left arrow key. Oh, well, okay then. Well, if that's the case, why don't we copy this and change if button 0, then text x equals text x. Now I want it to go in the opposite direction this time, -1. So now if I run the program, if I hit the right key, my text moves to the right. If I hit the left key, my text moves there, back and forth. So now we're using variables to move something on the screen. Well, the text is cool, but when you play like a game like Pac-Man or Mario, you have sprites. And sprites are little pictures that can be moved around on the screen. Now, pico-8 can handle sprites natively, has all the code in it. So let's make a little sprite. Sound like a happy little guy. How about we do a smiley face? Boom. Now, I am not an artist, as will become very apparent. But I think he looks fairly jolly, don't you? And why don't we do another one? But let's make him look less happy. So, now he looks a bit serious, doesn't he? So I want you to pay attention to the sprite numbers here, which are shown here. So that's 0, 0, that's 1, and that's 2. Right, so let's go back to our draw function here. Print. Now, we don't really need that anymore, do we? So let's get rid of that. Let's do sprite 1. Well, there he is. We've made a little happy smiley face there. Well, okay, what if we did sprite 2 instead? Oh, now he looks sad. But I don't want him there. Let's put him there. Now he's in the middle of the screen. But what if you wanted to move him around? It's the same thing. So text X and text Y. I've made a mistake there. There we go. Text Y. And now if I... Oh, hang on. My arrow keys now work still, because I'm still modifying the variables for text X and text Y, but now I'm applying it to a sprite rather than to a text field. That's good. Now, let's say our happy little guy here, or unhappy as might be, let's say he loves going left, but he hates going right. So let's change the variable. Let's make another variable here. Right, now we don't need color anymore, so let's get rid of color, and we'll change that to sprite equals, right, let's try 1 to start with. So when the program starts, it says sprite equals 1. And now if we go to our draw here, and let's say sprite equals sprite. Now if I run, we have a mistake. Attempt perform arithmetic on global color, which is a nil value, because at the moment... Right, let's try that again. There we go. Sprite. Oh, he's happy again, because we selected sprite number 1 when we did the variable. We declared the variable for sprite. So why have you done that, Chris? Well, because, remember, if button 1, which is the right arrow... Now, did we say our guy would like to go on right and hate going left? Yes, we did, didn't we? And then we can say sprite equals 1. And here, when he's going left, we say sprite equals 2. And if I run this... Oh, he's happy. Oh, he's not so happy. Now he's happy again. Oh, he's not happy now. Oh, he's happy. Unhappy, happy, happy, unhappy, happy. You know what I mean? So that's the basic animation. So imagine if you had, say, a spaceship. You could have a spaceship going, and then when you moved it, like that, you know? Well, that's cool, but shall we make our happy dude make a noise as he runs around? Yes, why not? Let's find something here. This is the sound editor. So let's, I like that one. Let's do that. Blop, blop, blop. Really can make... So all you're doing here is you're drawing out a waveform, basically. So if I wanted something that started off low and went up, and then down again. Too high. Right. And I want you to look at that. That's the number of the sound. Well, how do you play a sound? Well, if button 1, let's do, it's SFX is the command, 0. Okay? So when he's going right, he makes that sound. Okay? But no, it doesn't make a sound when he goes left, because he doesn't like going left. So the reason it's making that sort of grumbly, rumbly noise is because the sound is being constantly played whenever I press the button. There are ways to make that not happen, but it's a bit beyond the scope of what I'm doing here. So we've basically made a game, haven't we? It's not a particularly interesting game. Nothing happens in it. You've got a guy moving left and then right, you know. But that's a little bit of a basic idea about the pico-8 console. You can really go quite elaborate. I'm going to... there's a built-in function called explore, which stands for explore. And I'm going to quickly show you an example of a game running in this. So this is, as you can see, Tetris. Has sound, has physics, high score, well, you know. Chris, what are you doing? Dear me. There you go. Now, let's have a look at the code here. Ooh, look at all this. Now, this has got the code split into separate tabs on here. So as you can see, programming a full game of that standard isn't an easy task. But the pico-8 does make things slightly easier. So as you can see here, the sprites that they've made, they only use this as their map. And here are the sounds. So what we've got here are patterns. So you get your sounds and you put them into patterns, and then using the music editor, you put the patterns together. So yeah, as for the pico-8, I think it's brilliant. It's the sort of thing where programming tends to be a little bit dry, and it's very maths heavy, and it's not a lot of fun to work. But pico-8, because you get the immediate results, you can just jump in and you can just make something happen. And there's loads of good tutorials on YouTube. Definitely worth checking out. So yeah, pico-8, give it a go. There are other fantasy consoles out there. There's a couple of 16-bit ones. I haven't looked into them, but they kind of interest me as well. But yeah, I mean, even if you've never programmed before, the structured sequence within the pico-8, the whole function, initiate, update, and draw, it all makes perfect sense. So as long as you're methodical about it, you know, It's good. Anyway, that's all for that. Hope to see you again sometime soon. Thanks a lot, and goodbye.